This is the standard route for building AI into an app. The client routes requests through an auth server, into custom middleware, and out to the LLM API. It protects keys and manages memory, but every user prompt waits in line for server processing. But developers are now building multimodal experiences. We're looking at a Flutter application processing text, real-time audio, and high-resolution images simultaneously. Firebase AI Logic and the Flutter AI toolkit bypass that traditional server bottleneck. They allow you to execute heavy generative AI tasks securely, directly from the client. As this diagram shows, instead of routing through 3 layers of infrastructure, you establish a single direct connection from the mobile client to the Gemini API. You no longer have to build, maintain, or pay for custom orchestration middleware to connect your app to an AI model. To see how the client handles this routing securely, let's pull apart the presentation layer. Inside the client, the GenUI SDK sits beneath your Flutter widgets, orchestrating data to the AI agent. Using a pluggable API, you configure a Firebase provider to expose logic to the LLM chat view. Here, you specify your model, like Gemini 3 Pro Preview, to unlock its latest capabilities. Notice what is missing from this code block. There is no API key. The entire routing process happens locally, while the security credentials are fully abstracted away from the raw codebase and managed by the Firebase project. This raises an architectural problem. Without a backend server acting as a gatekeeper, how do you prevent unauthorized users from draining your API quota? The first line of defense is Firebase AppCheck. It intercepts and drops unverified requests before they ever reach the Gemini endpoint. It verifies the cryptographic authenticity of the app origin. If a malicious script tries to ping your endpoint, AppCheck blocks it. For large files like high-resolution video, the client doesn't send the massive payload directly to the API. Instead, it routes efficiently to cloud storage for Firebase. Here, Firebase security rules apply strict permissions, verifying only authorized users and the model can access it. By combining AppCheck for origin verification and security rules for file access, you establish a secure perimeter directly within the mobile client environment. Securing the data is only half the problem. The client also has to keep track of the conversation context across multiple turns. This visualization shows the traditional method for handling conversation history. Developers manually store every turn as an expanding JSON array and send that entire massive payload back and forth with every single request. Gemini 3 solves this problem using thought signatures. Instead of raw text history, the model outputs an encrypted data packet representing its internal reasoning process. The Firebase AI Logic SDKs capture this thought signature field and automatically append it to your next prompt, requiring no manual orchestration. The SDKs also manage data size. Gemini 3 processes vision inputs at a much higher default media resolution to catch fine details. Because high resolution increases token usage and latency, the client SDK introduces a configurable parameter, allowing you to manually balance the model's visual acuity against the speed of the output. The SDK absorbs the complexity of managing token limits, tracking thought signatures, and sizing input media. You just manage the UI state. We can push this client-side execution even further, into the realm of ultra-low latency, real-time conversational audio. Streaming text line by line is useful, but it is still a one-way street. A true conversation requires a bidirectional flow of data. To achieve that, we use the Gemini Live API alongside native audio models like Gemini 2.5 Flash. This animation shows the necessary shift. We abandon the standard stateless REST request cycle entirely. In your code, you instantiate a live model and explicitly set the response modality to audio. Under the hood, this single line of code creates a stateful WebSocket connection that remains active for the duration of the entire session. Audio data streams continuously in both directions. The user can interrupt the model mid-sentence and it will adapt its response immediately. You get natural, human-like conversational latency, completely bypassing the need to deploy and scale your own WebSocket infrastructure. This diagram reviews the complete synthesized stack. You have your Flutter UI layer, GenUI handling the orchestration, AppCheck securing the perimeter, and live WebSockets providing the connection. Now we add Firebase remote config to the deployment layer. Remote Config lets you adjust system instructions or swap model versions on the fly. You can change how the AI behaves across your entire user base without requiring them to download an App Store update. Building this architecture and managing the resulting widget trees requires a specific workflow. Anti-Gravity proactively edits files and runs terminal commands to complete complex tasks, moving the development experience beyond basic autocomplete suggestions. Powered by the Dart and Flutter MCP server, the AI agent has deep context into your project. It can introspect your widget tree, read live runtime errors, and proactively execute multi-step workflows to implement these architectures. Generative AI has evolved into a deeply integrated, real-time client-side architecture that runs securely and at scale.